Welcome to our first iTS4ZEB webinar. Today we are presenting a forward-looking European initiative that tackles one of the most urgent and complex challenges of our time, that is reducing greenhouse gas emission in the residential building sector, which accounts for over 1/3 of the final energy consumption in the European Union. Buildings represent a major front in the energy transition, especially when it comes to heating and cooling, which remain heavily reliant on fossil fuel. My name is Matteo Campidelli, and I am the Technical Manager of Innova Engineering, and I have the honor of serving as a project coordinator for iTS4ZEB. On behalf of the entire consortium, I would like to thank you for your joining us. Today we will walk you through the core of this ambitious project, co-funded by the LIFE program of the European Union and developed by a multidisciplinary team of researchers, engineers, industrial partners, and sustainability experts. The LIFE iTS4ZEB project is not just a technological solution, it's a strategic and systemic approach to decarbonizing European homes. Our focus is on providing compact, cost-effective and replicable solution that can drastically reduce CO2 emission while maintaining comfort and economic feasibility. Over the next 30 minutes, we will explore the technical rationale, the system architecture, and the deployment strategy of the project. We will show how latent thermal energy storage, when combined with the renewable generation and smart control, can bring the concept of zero-emission building from policy papers to practical implementation. So let's begin our journey toward a smarter and more sustainable build environmental. So energy consumption continues to rise globally, and buildings are at the center of this trend. Since 2010, total global energy use has grown by almost 20%. Although renewable energy technology have expanded, approximately 80% of the additional demand are still being met by fossil fuels. This points to a significant structural lag in our energy systems. Technology is evolving, but our usage and infrastructure are not transitioning fast enough. The building sector, in particular, is problematic. It accounts for more than half of global final energy consumption. In the European Union, residential and tertiary buildings are responsible for over 40% of energy usage and 36% of CO2 emission. These figures are even more striking when we consider that much of this energy is still used for heating domestic water and cooling, often delivery through systems based on fossil fuel or inefficient use of electricity. The present these represent a massive bottleneck. If we don't reduce building energy demand and shift it to clean energy resource, the European Union will not achieve its climate goal under the Green Deal, Fit for 55 or Repower EU strategies. The solution requires an integrated approach that goes beyond equipment efficiency. We need a system that can shift load, store energy intelligently, and integrate seamlessly into both new building and retrofit context. This is the precise space in which iTS4ZEB operates, by combining renewables, thermal storage, and intelligent control. The project proposes a practical, scalable response to one of the European Union's most urgent energy challenges. In the path toward meeting the European 27 climate targets for 2030, the residential building sector must rapidly shift to integrated low-emission energy system. The combination of photovoltaic panels and electric heat pumps is often presented as a solution to decarbonize heating and cooling. Both technologies are mature, market-ready, and increasingly accessible. However, there is a major limitation that hinders their full potential, the mismatch between energy production and energy demand. Solar energy is intermittent. It follows weather conditions and daylight cycle, not the comfort needs of occupants. In winter, for instance, its demand peaks is in the early morning and evening, precisely when PV production is at its lowest. In summer, solar panels produce more energy than needed, particularly in the afternoon when demand is low. Without storage, this leads to waste, over-reliance on the grid, and inefficient operation of the heating and cooling system. This is where thermal energy storage becomes a game changer. It allows renewable energy to be stored as heat and used later when needed. Thermal energy storage doesn't just increase self-consumption of PV, it also enhances grid stability, flattens demand peaks, and improves energy system resilience. iTS4ZEB proposes a solution that integrates latent heat storage using phase change material, PCMs, which has smart control logic and multi-source heat pumps. The system dynamically balances generation and demand in real time under real operating conditions. It offers an adaptable, compact, and highly efficient solution that is not only technically sound, but also scalable across diverse building time and climates in Europe. The foundation of the project is firmly aligned with the European Union Strategic Energy and Climate Framework, particularly the Clean Energy for All Europeans package, which form the backbone of Europe's energy transition policy. This package is not just a legislative milestone, it serves as a comprehensive roadmap for delivering on the Paris Agreement, the Green Deal, and Fit for 55 objectives. The policy defines three core priorities: energy efficient first, reducing consumption before increasing supply; global leadership in renewable, accelerating the deployment of clean technology; a fair deal for consumers, empowering households to become active participants in the energy system. To meet this goal, heat pumps are considered a key enabling technology. They offer an efficient and electrified alternative to fossil fuel-based heating and cooling. However, on their own, heat pumps are not sufficient, particularly in buildings where solar energy availability and thermal demand are not synchronized. This is specifically true for retrofits in dense urban areas or during seasonal fluctuation. That is where thermal energy storage becomes a critical component. iTS4ZEB introduced a compact, modular, TERS system based on phase material, which store and release heat at constant temperature with high energetic density. This system complemented heat pumps, allowing better alignment between renewable energy generation and use. By integrating storage directly into building system, the project provides not just a technical upgrade, but a tool for policy compliance, energy autonomy, and ultimately decarbonization at scale. The heart of iTS4ZEB project lies in its integration solution, a next-generation system that combines high-efficiency heat pump with intelligent thermal energy storage, all managed through smart control logic to adapt to real-world conditions. The overachieving this goal is make zero-emission building a practical and scalable reality across Europe, not just in new construction, but also and especially in the existing stock, which represent the majority of energy consumption and carbon emissions in the European residential sector. When sets iTS4ZEB apart, its focus on modularity, replicability, and user-centric design. The system integrates a propane-based low GWP heat pump, which a latent thermal energy storage using PCM. This configuration enables the storage and release of heat at stable temperature, increasing both comfort and efficiency while reducing electricity demand during peak hours. Unlike many demonstration projects that remain confined to the lab or simulation environment, this system is engineered for real deploying in actual residential building. It is compact enough to be installed in constrained spaces and flexible enough to be adapted to a wide range of heating configuration, including radiators, floor heating, and domestic hot water supply. To ensure robustness and transferability, the project is conducting field validation across 10 European countries, covering a variety of climates, building typologies, and usage profile. This broad testing strategy will allow the consortium to gather operational data, assess user interaction, and prepare the system for future market rollout. Let's take a moment to recognize the strength and composition of iTS4ZEB consortium. 6 complementary partners and 1 affiliate entity, all from Italy and Germany. The consortium brings together industrial leaders like Innova, that is the Italian company coordinating the project, supported by its affiliated engineer branch, Innova Engineering. They bring production innovative, prototyping, and market knowledge to the core of iTS4ZEB. Then there is Panasonic Marketing Europe, that is a global player ensuring wide-scale deployment and strong market positioning. There are research and academic institutions, so University of Padua, leading experimental validation and dissemination, with a deep know-how in thermal system, advances exchanger, and additive manufacturing. Europe Research, which expertise in energy system modeling and lab testing of innovative energy technologies. Then there are technical partners in sustainability and implementation, like Studio Fieschi, that is a specialist of life cycle analysis and environmental footprinting analysis, leading the monitoring and assessment work package. And then there is Sun Service, that is a company expertise in thermal storage integration and deployment of technology in real world. Each partner represents a specific and critical perspective, industrial, academic, technical, or sustainability driven. This tight interdisciplinary team allows us to bring innovation and application, ensuring that iTS4ZEB is scientifically robust, technologically advanced, and ready to scale across Europe. The iTS4ZEB project has been structured around a set of well-defined technical objectives, which respond directly to current gap in residential energy system and are designed to maximize environmental, economic, and operational impact. The first goal is provide a cost-effective alternative to electrical batteries. While batteries play a crucial role in energy transition, they come with high cost, material constraints, and environmental concerns related to their manufacturing and end-of-life management. Thermal energy storage, particularly in the form adopted by iTS4ZEB, offer significantly lower cost per kilowatt stored, greater durability and minimal ecological footprint, especially when integrated with the existing heating system. Secondly, the system is designed to unlock the full potential of rooftop photovoltaics. By storing excess of PV generation and thermal energy, households can increase their self-consumption, reduce grid dependence, and improve the utilization of solar resources. This means solar energy can be used not only for electricity, but also for space heating and domestic hot water, even when the sun isn't shining. Third, we prioritize ease of integration. The system is designed for plug-and-play deployment, minimizing disruption of the existing structures. Its modular design allows it to be scaled based on building type, available space, and energy needs, while remaining compatible with a wide range of AVAC configurations. Finally, the process supports the smart grid ecosystem by enabling load shifting and demand response. The system intelligently stores it during periods of surplus electricity, especially from renewables, and release it when demand is high, stabilizing the grid and supporting future energy flexibility. Finally, we include a hybrid integration with gas boiler, bridging current system with future-ready solutions without costly overhauls. When designing technology for residential use, functionality alone is not enough. Energy systems must integrate not only with electrical and hydraulic infrastructure, but also with the architectural and aesthetic character of the home. This is especially true in Europe, where building stocks is different, dense, and often protected by historical preservation constraints. That's why one of the design priority of iTS4ZEB has been form factor and flexibility. The system is convincing to be elegant and compact and unobstructed, both visually and acoustically. It was engineered with real installation scenario in mind: small apartments, utility closet, multi-family basement, or external courtyards. The energy storage module can be installed in vertical stacks or distributed laterally in low clearance spaces. This modularity allows installers to adapt to different spatial configuration without compromising performance. Moreover, the heat pump unit, powered by environmental friendly propane, can be installed remotely, providing even more architectural freedom and facilitating integration into homes where the indoor footprint must be minimized. This flexibility also applies to retrofits. The system can coexist with existing gas boiler, radiator, or hydronic network, supporting progressive renovation paths without requiring full system overhauls. It respects the building as it is while preparing it for the future standard. Ultimately, the system is designed to be invisible in everyday life, operating silently, automatically, and efficiently in the background. Residents benefit from stable comfort and reduced energy costs while contributing to the decarbonization. Technology should serve people, not disrupt their living environment. And this is precisely what iTS4ZEB aims to deliver. We now turn one of the real-world configuration where iTS4ZEB system demonstrates its full potential: centralized heating system in multifamily buildings. In this user case, a centralized air-to-water heat pump is installed to serve multiple residential units through a shared hydronic distribution network. This configuration is particularly common in European urban scenario, where many apartment buildings from the 1950s and 1990s are equipped with collective heating system, often based on fossil fuels. Rather than requiring full replacement of the legacy system, iTS4ZEB proposes a targeted upgrade, maintaining the existing distribution infrastructure, but replacing or complementing the thermal generation units with a cleaner, smarter system. The energy source is a combination of rooftop photovoltaic panel and grid electricity during period of solar availability. The PV system supplies electricity to run the heat pump, and any excess energy can be stored thermally in the test. When demand spikes or renewable production is insufficient, the existing gas boiler acts as a backup, maintaining comfort without requiring immediate removal of legacy component. This approach provides multiple benefits: decarbonization without radical destruction of existing building system, improved self-consumption of solar energy, load balancing across different apartments, and scalability across district or public housing stock. It is a realistic and cost-effective retrofit strategy that enables building owner and energy managers to start reducing emission immediately without waiting for full building overhauls or deep renovation. iTS4ZEB thus positions itself as a catalyst for traditional decarbonization across Europe's aging multifamily housing stock. Another important application for the iTS4ZEB system is found in decentralized configuration for multifamily housing, where each apartment is equipped with its own air-to-water heat pump and dedicated thermal energy storage unit. This approach contrasts with the decentralized system in the thermal generation and storage are managed at the individual dwelling level. Each residential unit gains a degree of energy autonomy, enabling tailored operation based on occupancy, user behavior, and specific comfort need. This structure is especially used in buildings where residents have individual ownership or varying renovation preferences. One of the main advantages is flexibility. Not all residents in a multifamily building may agree on a collective renovation effort or centralized system overhaul. With this decentralized approach, individual apartments can be upgraded independently, reducing administrative complexity and supporting step-by-step renovation pathways. Moreover, decentralized systems enable load balancing at the building scale. When all systems are running on low demand, each unit operates autonomously. During peak load or grid constraint, a residual central heating system, such as a gas boiler, can provide support, ensuring continuous comfort and supply security. This hybrid structure reduces dependence on fluid while keeping legacy infrastructure operational during transition phase. By enabling distributed decision-making and scalable investment, iTS4ZEB supports socially inclusive renovation model where building owners, cooperatives, or tenants can choose their level of participation. It aligns with European goals on energy empowerment, while addressing the very practical realities of managing energy transition in a heterogeneous housing block. Another deployment configuration within iTS4ZEB focus on water-to-water systems, which are particularly sustainable for multifamily and commercial buildings that already operate with anhydronic distribution loops connecting each generation to terminal unit, such as radiator, fan coil, or underfloor system. Contrary to common assumption, water-to-water in this context is not synonymous with geothermal system. Rather is a hydraulic strategy that allows the iTS4ZEB solution to be installed directly in line between the generator and the distribution loop, acting as a buffer that can store and release thermal energy with minimal hydraulic or control system reconfiguration. This makes it an ideal choice for buildings where the hydronic backbone is already in place, but the generation logic requires decarbonization. The system operates in synergy with the PV-generated electricity, which is used to power the heat pump and charge the TES during low demand or high production period. When demand increases, the stored heat is released into the loop, and only when necessary is the auxiliary boiler engaged, thereby reducing fossil fuel dependencies. To further diversify deployment pathways, iTS4ZEB introduced a simplified system configuration in which the TES unit is not a standalone thermal buffer, but rather a functional accessory to the heat pump. In this variant, the thermal energy storage is delivered as an indoor unit, offered in kit together with the heat pump, and designed to operate with a tight control logic integration. This solution does not require complex plumbing or third-party control system. Instead, the thermal energy storage interacts directly with the heat pump operational cycle, storing and releasing thermal energy based on internal logic managed by the heat pump controller. It simplifies installation and commissioning, making it ideal for residential building and single-family houses, especially where space is limited and installation time need to be minimized. Rather than re-engineering the entire heating infrastructure, this approach offers a ready-to-install package with seamlessly extend the functionality of the heat pump and enhance its energy performance. It allows manufacturers and installers to promote thermal storage not as a separate system, but as a native component of the decarbonized AVSC solution. The combination of a flexible water-to-water setup and a plug-and-play variant demonstrates iTS4ZEB commitment to offer versatile and scalable thermal storage integration across the wide range of building scenarios. The iTS4ZEB system is fully adaptable to single-family homes, offering two distinct installation approaches that both rely on the same core technology, latent thermal energy storage. In both configurations, the thermal energy storage plays a critical role in decoupling energy production from energy use, but the way it is integrated and charged different based on building type and system requirements. In retrofit situation, where existing hydronic circuits and fixed temperature set point must be preserved, the system uses a water-to-water configuration. Here, the TES is connected to the main hydraulic loop, and the heat pump includes a second internal stage specifically designed to charge the storage even with lower temperature water, without affecting the supply to the terminal unit. This ensures energy can be stored and reused flexibly, regardless of the operating regime of the heating system. In contrast, for new installation, a simplified configuration is offered. In this case, the test is still present, but as a part of pre-assembled hydraulic kit, sold together with the heat pump. The system includes a valve module that enables the switching between direct supply to terminal and storage charging. However, in this version, charging the test requires that the central generator modulates its output, either by increasing flow temperature or alternating flow direction, according to the control logic. Both variants offer strong performance, but serve different integration strategies. The water-to-water system maximizes flexibility and independence from system condition. The simplified kit prioritizes ease of installation, compactness, and standardized operation, ideal for the new buildings or preferred system architectures. iTS4ZEB dual approach ensures that storage integration is never a barrier, only an opportunity for decarbonization. One of the most practical and widely replicable iTS4ZEB configuration is based on an air-to-water heat pump integrated into the hydronic system with a hydraulic separator or directly coupled on the piping system, designed specifically to coexist with an existing gas boiler. This approach is particularly well suited for progressive retrofitting, where the objective is not to eliminate the legacy heating system immediately, but to significantly reduce its usage by integrating a renewable-based primary source. The heat pump handles the majority of the annual heating demand, while the gas boiler remains available only for peak loads, such as extreme cold spells or high domestic hot water consumption. A key component of this setup is the test unit, which is positioned downstream of the heat pump. It allows renewable electricity, often from one-side photovoltaics, to be stored as a heat when available and dispatched when needed. This leads to greater self-consumption, reduced operational hours of the boiler, and a marked decrease in emission and energy bill. The hydraulic separator ensures that both systems, heat pump and boiler, operate independently, maintaining thermal and hydraulic balance, even in complex retrofit environmental. The control logic orchestrates the interaction between components, giving priority to the heat pump and activating the boiler only when storage and renewable are insufficient. This hybrid configuration reflects a realistic pathway for energy transition in Europe's existing building stock, enabling decarbonization without imposing radical system overhauls while preserving occupant comfort and operational reliability. Beyond heating, the iTS4ZEB system is designed to contribute to domestic water production, covering a year-round energy demand and extending the usefulness of thermal storage beyond the heating season. However, it's important to clarify that in this scenario, the thermal energy storage is not intended to act as a primary domestic water generator, but rather as a support element that enhances efficiency and renewable utilization. This support role can be implemented in two different ways, depending on the hydraulic configuration of the system. In the first approach, the thermal energy storage is built with a dual circuit structure. In this layout, the domestic water is preheated as it passes through the heat exchanger coil inside the thermal energy storage before being further brought to the desired temperature by the primary generator, heat pump, or auxiliary heater. This ensures that the water enters the main heating circuit at a higher baseline temperature, reducing energy demand and improving responsiveness. The second approach involves the use of a three-way valve system where the test can directly serve technical water loop used for domestic water preparation, effectively becoming an alternative source of heat when surplus energy is available. This configuration increases system flexibility and maximizes the use of stored renewable energy. Leveraging the test for domestic water preparation is especially valuable from a seasonal optimization standpoint. During periods when space heating is not required, such as springs and summer, the test continues to provide functional value by shifting electrical loads, increasing PV self-consumption, and reducing grid dependence, even in not heating months. This multi-role capability further enhances the replicability of iS4ZEB in European residential context, aligning with energy efficiency target and user comfort requirements year-round. A critical component of the iS4ZEB project is its commitment to field deployment across a broad geographical and climatic spectrum, demonstrating the system in real home with real users and under real operating conditions is essential to provide both its technical performance and market replicability. A total of 50 iS4ZEB units are being installed in 10 European countries: Croatia, Denmark, France, Germany, Hungary, Italy, Slovenia, Spain, and Sweden, and the Netherlands. This diversity is not incidental. It is a strategic choice that allows the project to validate system performance under different climate conditions, from Mediterranean to continental and Northern European context, test compatibility with a wide range of building typologies, including single-family homes, apartment, and multifamily blocks, address different regulatory frameworks, installation practice, and user behavior, thereby ensuring scalability and replicability across European markets. As of today, 18 units are already being installed and commissioned, with data collecting underway. This includes monitoring of energy flow, comfort level, heat pump performance, and user interaction. Importantly, the field test phase has officially begun, and the project is now entering in its first winter with test units in full operation. This upcoming heating season will be pivotal for assessing system resilience, storage efficiency, and the ability to shift load and reduce fossil fuel use during peak demand periods. These operational insights will feed directly into the final system design, the exploitation roadmap, and the evaluation of environmental and economic performance across the life cycle. The iS4ZEB validation strategy is a comprehensive, aiming to confirm the system performance through both control and laboratory protocols and real-world deployment data, ensuring scientific credibility, regulatory alignment, and market readiness. In the laboratory, the project is validating the solution through experimental testing of system configuration and operating modes, numerical simulation to explore broader use of scenario and climate condition, modeling of thermodynamics and integration behavior, life cycle assessment to qualify environmental impact and support eco-design claim. In the field, the team is collecting real-world performance data from 50 demonstrators in 10 European countries. This includes heating and domestic water use, both photovoltaic self-consumption rates, load shifting capability, user comfort, and behavioral response. But validation alone is not enough. The project also targets the development of new standards to ensure future commercial products can be compared and fairly assessed. This includes a method for measuring heat pump plus test system in lab environments, building on standards like EN 14511 and EN 60147, adapted to capture the impact of integrated storage. A proposal to update APBD methodologies, EN 15316, to explicitly include the contribution of thermal storage in building energy performance ratings. This step is crucial for commercial exploitation. Without a recognized performance pathway, thermal storage solution risk being undervaluated in public tenders, energy labels, and incentive schemes. The project ambition to reach mass production readiness by the end of the founding period, the product is being designed with this goal in mind: modular, manufacturable, and scale, and compliant with evolving EU directives. Exploitation activities are already underway, focusing on scalability across residential typologies, replicability, especially for domestic water application, which offer year-round value, alignment with market channels and installers, positioning the solution and as an energy upgrade for both new construction and retrofits. Finally, dissemination activities plays a key role in supporting uptake, ensuring that decision maker, regulator, manufacturers, and citizens all recognize the added value of smart thermal storage in the energy transition. Thank you for your attention and interest in iTS4ZEB project. If you want to know more, follow us on social media, just searching for iTS4ZEB or LinkedIn and Instagram. You will find updates on our field test, video from the installation, partner insight, and opportunity to engage with the project. We look forward to continuing the conversation and working together toward our future of smarter, cleaner, and more resilient homes across Europe. So if there are any questions, please just write in the Q&A section of the webinar.